Let's start. My name is Artur Szymański. I'm head of art department at Simteract. I'm art director there, and I supervise technical art, which is a lot of fun. I'm generalist, but right now I dabble mostly in technical art, and my software of choice is Houdini. And I spend quite a lot of time working on shaders in Unreal, so both systems are node-based. Simteract is a Krakow-based company. We work on simulation games, not hardcore simulators, more like chill-out, relaxing sessions of a game, not unlike Eurotrack Simulator. Those are types of games we are creating. And today I will be talking about process of creating game world for our game Train Life that was released 2 years ago. The first aspect of this was understanding what kind of game world we'll be talking about. And design team decided we should focus on a big chunk of Europe, but not into one-to-one scale, because then we would have very long gameplay sessions, and basically we would have to stream those levels, and we didn't have infrastructure for something like this. So scaling down the world was a reasonable assumption. But this gives us a lot of potential problems that we had to solve. For example, one cannot just scale down cities. The landmarks wouldn't fit. The buildings would be misaligned with the road structure. It would look just wrong. So we decided that we will focus on just small parts of the city that are relevant to railways, so railway stations and surrounding areas. And those will be recreated in one-to-one scale, and all the rest will be just removed. But even outside of cities, there are places that are problematic. For example, this example of such place, the loop tunnel in a circular shape that's near the German and Switzerland border, and it's 600 meters diameter. So it's huge, but in terms of railway transportation, it's actually a very tight loop. This scaled down by a factor of 20 would give us something that would be more in place with a roller coaster, not in trains. So things like this just cannot be scaled down. And we decide with approach that the world will not be uniformly scaled. And this is the same structure that we're seeing here. And this structure in this preliminary design was decided things like this will be left in one-to-one scale, as long as centers of the cities and all the rest will be subject to being removed and cut from the game. And that led us to the first draft of world design. This is the 8 by 8 kilometer tile that encompasses this city. That's actually here, Basil and Basilea, just a part of the city that's important for railway travel. And this structure that we see here in one-to-one scale recreated here. And as you can see, all this part is just cut, replaced by 1 kilometer long part of the road. And those assumptions gave us the game world, first version of game world. And we have here 76 tiles, 8 by 8 kilometers, which is almost 5,000 square kilometers of landscape. Not streamed, but as a part of a game world and game. Well, and it spans from the shores of England to Poland. And as an art team and technical art team, we were tasked to find a way to recreate this game world in our game, and in a reasonable time with the team that we had at that point, 2 level designers and 3 level artists. Not small team by any means, but challenging for this kind of world. So we had to thought about tools that allows us to make everything faster. And we couldn't use existing tools, because there's a lot of tools that allows to take existing vector data and recreate parts of the world one-to-one. As you saw, our world will be very disjointed and like sew together. Again, so we can't use exact real-world data. But we did nevertheless as a base of our work. This is a part of the data in Houdini imported from OpenStreetMaps. This is open database that encompasses a huge amount of data about world. Some parts of the world are recreated better, some are worse, but Europe is generally very well documented there. And this data, after some cleaning in Houdini, we are able to gather a lot of knowledge about the parts of the world that we'll be recreating. And I will show the process we are implementing on this just part of the road, 2 places. Looks like spline, but actually with magnification, this is entire road structure with switches. It's simplified, but it was just enough that after sending to our code team, the code team was able to recreate road structure, track structure, and build game logic based on this. So what's left was to create world around this. And part of the data that we had was data about buildings, landmarks, and informations about landscapes, like forests, like mountains. And all of this, while we couldn't just rescale it, we could use in our process of recreating the world. And we start by automatizing process of finding those important parts that were not subject to being rescaled. And we call this excitement analysis. This is the same part that you see here. We're finding buildings, or landmarks around those tracks. We're finding buildings, a curvature of tracks, and stations and switches. Those are actually all those structures were very simply defined because all data in OpenStreetMaps is tagged. So just by filtering this in Houdini, we're able to find all those elements, and curvature is simple to calculate. And based on this data, we created for every part that we were interested in contracting, created heat map of how much part is important to the entire track, that we shouldn't contract it, and we should leave it in 1-to-1 scale. And from this, we had filtered part of tracks that we just should leave unchanged, and then we could just contract those and sew together. And for every part, in Houdini, the surrounding data, for a given radius, the surrounding data was added. So then we could move the parts of the tracks independently, but with all those informations about buildings, about landmarks, about landscape together with those parts of the tracks. So the surrounding areas for the tracks we'll be recreating will be unchanged and will have exact data from real world, and the other parts can be just removed. So those all parts are here connected. And from those informations for parts of the tracks that we were using in game, those parts were added together, and from those tiles, information about those parts were baked into the tiles, along with data of road structure that were given to the code to recreate road structure. And from this information, we could start building our game world. And all of those was built. This could be built in many ways. There is a very good software for creating landscapes from this kind of splat data. It's World Machine. We use it earlier in our earlier productions, but at this project it was important for level artists to give them feedback, so they could, as you can see, there's a lot of things that needs to be filled up here, and we decided those, because those are far away from the player, because we knew exactly where the player will be on the game, then we haven't used exact data, just allows a level artist to work on those areas with big painting brushes, so they could feel those missing areas. But that would work only if we allow for feedback. quite fast. So we've decided to use Houdini engine and connected this world generating part with Unreal directly. And this is an example how this would work. This is an example from Houdini, but actually all of those steps happened in Unreal. With mask painting tools, level artists were able to just block some areas that want to be covered by forest or being mountains, being hills. And then very quick process of adding a couple of layers of noise that was multiplied by those masks, created very simplified version of the mountains. Those are here mountains as an example, but we had different layers for different types of environment. This was very fast. Of course, those mountains were very crude and not realistic looking, but gave quite a good impression of final look of the tile. And this part was very fast to generate. Then after a couple of iterations, when we had acceptable terrain that was looking good, the actual algorithms for erosion could be implemented, and we had final version. And while going from this to this in Houdini engine took a couple of seconds, then going from this to this part was about, I think, in final version, about 10 minutes, so a coffee break. And along with those erosion simulations, we had informations about potential snow cover, about range of forests, and type of objects that we'll then use in Unreal for generating proper landscape material. And this is an example from a talk 2 years ago when I was talking about this system specifically. We have in Unreal a couple of those splat maps, and then after 10 minutes we've got a landscape generated with Houdini engine and the data for landscape generation and for landscape materials used here. And we have landscape. All those trees, for example, that are here, are made with this system of grass nodes. This is basically a grass, but scaled up and with different models. So all of this is procedurally generated. It's very fast. It doesn't look good up close, but that was not a problem, because up close we had railways and tracks, and we were actually more at that stage of production. We were in world generation. We were creating those parts that were like 50, 60 meters from tracks and more. But what about those elements that were much closer to the tracks? Because with those systems, with tracks generated from splines by code, and with buildings generated from OpenStreetData, we came up with the amount of that's something visuals that looks like this. So we've got tracks, we've got third plane horizon, but we are severely lacking details here and here. And of course, we could task level artists to fill up those areas. But again, the game world was huge, so that would take much more than that was reasonable in this product. So for those, because we had those splines that were generating tracks, so we could easily average those splines, and for every road connection I had exactly one main spline in the middle. And for those, we've created blueprints that along the spline were scattering slightly randomized objects, and some of the objects could even be bent just like tracks. That allows to create a set of blueprints, we call them corridors, that assigned to any part of the tracks could change from this to this. So spawn a lot of objects that made this game world very near our tracks much more interesting. And with a couple of presets of those, the level art team were able to very quickly populate dozens of kilometers of tracks. And then, thanks to this, the team could focus on parts that were more important to recreate with better quality, like cities, where trains will slow down and we needed much more human touch in those areas. So all those long generic, kind of generic parts were automatized that way thanks to blueprints. And at this point, everything was going really, really nicely. We were able to recreate most of the world we planned, and our plan was to start working on a Nintendo Switch, because from the get-go we knew that the game will be on PC and consoles, older gen, but also there will be Nintendo Switch version. It couldn't really start working any sooner on this version, because quite late into production we actually get development kits for Nintendo Switch. But it's not like we didn't have a plan. We had a plan, so we weren't worried about this, because of course the entire game won't fit on the cartridge. But we decided that we'll put on the Nintendo Switch memory card just the tutorial level, so one landscape, and then the rest will be as downloadable content downloaded in background during the tutorial session. It made sense, and 16 gigabytes for tutorial level seemed like absolutely doable thing. It's a lot of data. And when it comes to performance, we assume that just decreasing textures, texture qualities, and because people are okay with the fact that games on Switch looked slightly better than on PC and consoles. So we should be good to go with just decreasing textures and decreasing visibility. But in the meantime, the plans were changed. We found out from publisher, yeah, it was not that fun. It definitely was a very silent moment when we found out. The entire game had to be fit on memory card. Because of manufacturing costs, the memory card will be 8 gigabytes, not 16. Any downloadable content will be for patches and potential DLCs, but the entire game has to be on a Switch. An entire game. We couldn't make different version that's just smaller, just cut out. No, entire game. And we tested if our assumption about just decreasing textures will be okay. No, it wasn't. So that was probably the most stressful moment in a production. But it leads to a lot of very interesting findings. So it was not all bad. We start working on this, and while our team was crying about this, the code was actually working really hard to putting our game on Switch. Because, yes, there were huge challenges, potential challenges on the art to fit everything there, but the code was always also in huge pain, because putting the game that was not exactly designed on mobile device into Switch, game of such magnitude, was not an easy task. But they managed to do this. And soon I got my development kit and was able to run our game, just one landscape for testing purposes, to see where are we there. And the game ran. It looked like this. At that point, without compression, our game was 100 gigabytes in size. So we've got a mathematical formula that shows the problem that we had. And this is the look we had, and it ran. It ran, the UI worked, so everything was great. At that point, we start cutting everything that was possible to cut. We changed texture scale to something like 128 by 128, just to see if we are even able to do anything. We found out that those problems with shaders are caused by lack of memory. We found out that lack of anything is caused by amount of dynamic lights that were used. If it's more than 4, then it looks like this. So we kept just front train light and sun. It was the only light that were left in game with dynamic lighting. And we cut everything that's possible. And the first optimization looked like this. Complete texture resolution decreased to the point where it was blurry and like impossible to find out what the texture even was. We changed landscape tessellation. Some, LODs, 0 and sometimes even 1 were removed from objects. That actually didn't cause too much of a problem because even LOD2 looked not bad, so it was not such a big deal. We decreased shadow quality as much as possible. We removed all post-processes. Removing ambient occlusion was the saddest part. And we decreased resolution, rendering resolution to 70% and then upscaled everything. And the game looked better. It ran like 7 frames per second on one landscape and looked like this. And game world was done. It's not like we could change anything significant because that would mean a very significant change of release date and changing budgets completely, and we couldn't afford this. So we had to think about much stronger optimization than this. And first thing, at this point, after cutting LOD 0 and 1 and cutting textures and adding compression, the game was about 38, 40 gigabytes. So significantly smaller, but still much higher than 8. So I thought about where are else place we could cut. And the only candidate was landscapes. Because landscapes are actually takes huge amount of data. The height field is 16-bit texture, 8 by 8, to gives us a precision of 1 by 1 meter per pixel. Every landscape with masks takes in Unreal about 300 to 500 megabytes. And this is before some additional assets that spread there. So this was the most main culprit of not being able to fit on this memory stick. So we had to do something about this. And we decided that in Houdini, we will use procedure that every landscape that is tessellated and generated with high field will be converted to static mesh. And because we know exactly where the player is, this static mesh will be slightly denser near the tracks and just decimated anywhere else. And all the materials and texture will be simply baked into texture. It was not perfect by any means. We had a huge problem with foliage. As you saw, the foliage, all this faraway foliage was generated as a grass, with grass node, and that in Unreal works only with landscapes. So we lost all the trees in the world in the process. But at that point, that was the least of our problems. And this is the highly optimized landscape that we end up with. And those were much, much lighter. The difference was huge. It was, at that point, it was 100 times less data. But it also, even with keeping a lot of details near the tracks, it was not precise enough not to look horrible near the tracks. So for this, we actually changed the mesh. And thanks to the fact that all this was created procedurally with blueprints, we were able to change meshes of tracks and add some part of terrain into those tracks. So very unprecise terrain, and then over this, precise tracks with parts of gravel terrain, which helped a lot. Then, additional problem arise. With mobile devices, the fog in Unreal is realized in a completely different way. Ordinarily, it's created with a depth mask and the depth buffer. But on mobiles, it's using, which we then find out, vertex color, which means it looks great when we have a lot of vertex. And with this optimized landscape, we didn't have a lot of vertex. So this was our foggy landscape. Some triangles were just absolutely visible. But with this approach, we suddenly were starting to see possibility to fit on this cartridge. So we decide that the probability of experiencing foggy weather will be set to 0, hence solving fog problem. Another very big optimization, performance-wise, was optimizing shader complexity. We basically removed, there are some small optimization here and there, but we basically removed translucent objects completely. Everything that was translucent in the game was replaced by masked materials, which are significantly cheaper, looking slightly worse, but the difference was huge. Something that really doesn't matter in high-end specs PCs, but on Switch, that was a big deal. And on things that couldn't be just visible or not, like particle effects, detailing effect was used. So some parts were alternately visible and invisible, and because of the use of temporal anti-aliasing, those elements gave impression of being translucent. It works well enough for something that's far away, but for objects that are close to the player, the illusion breaks. There's a lot of ghosting. So for things that are close and transparent, like glasses, like glass on windshields, we just remove them completely. So we had very transparent glass in trains. So general thought is, don't be afraid huge and strong moves, because those are really necessary in optimization that goes that far. And all of those things suddenly meant that our game started to fit on this memory stick, but still looked like garbage, and performance was really, really bad. And we found out that during testing that actually there are two moments that games starting to look not as bad and starting to have nice performance. At night and during full cast weather, when there is no direct sunlight. And we found out that removing every dynamic light in the game helps a lot, which is not surprising, to be honest. Shadow casting is a process that is very expensive, so removing lights removes shadow casting. And we removed sun from the game, just by setting cloudy weather to probability 1. And then we removed front lights from the train, and we add 2 beautiful emissive decals. And those work really well. And with those adjustments, a game started to run not only okay, it started to run well enough to actually reintroduce ambient occlusion and increase resolution, render resolution back to 100%, which was the biggest problem with early versions because upscaling looked really bad on small screen. And the game looked better, but looked weird and different, which we had to accept. But then it is more important, it's very important for visuals to look intended. So we then thought, what can we do to use those all changes to our advantage? And we actually end up with increasing ambient occlusion quite significantly and increasing saturation of textures that we actually could, some chosen textures that are near to the player, we could increase the resolution back to something that was acceptable. And we came up with, end up with a slightly stylized look, but that didn't look quite bad. It was visually different game than the PC version, but look intended. And here are the versions before those changes, and here after. And I wouldn't say the smaller screen and this view doesn't give them justice. this was a blurry mess. Those shadows that are here are barely visible. And this was more stylized look that now I know is the reason why a lot of games on Switch are stylized, because it solves a lot of issues when you don't have to render dynamic shadows and dynamic light. And the game looking like this, again, no glass here, ran surprisingly well and was actually shipped. And what was really unexpected for us, the Switch ended up being, from data we gathered, second best-selling platform after PC. So it was all worth it, and the amount of things we learned was very, very significant. Yeah, I have to add that this was made as a part of NCBR grant. And right now, I have a little bit of time. One more thing that may be interesting. It's about problem that we encounter during working on this game. That was absolutely avoidable on a couple of stages. And this may be probably the most important thing if you ever take something from the stock, this may be this. Not to be not to be afraid to throw out some of part of the work if in the long run it will save a lot of time, potentially. Because with this design, level design, there are places in the world, yeah, of course, then the track goes from one landscape to other. Like a lot of places like this. And at that moment, Unreal will have to load both landscapes and assets for both landscapes. We're using word composition, so this was done automatically and worked. There was no problem there. But sometimes our tracks were built and designed that way that weren't like this. Not many places like this, but there were on this map. And when a player reached those places, 4 landscapes have to be loaded. And we knew from the beginning that it's not great, but it was impossible to find out how much of a problem this will be, because it was very early stage of production, so no optimization at all, everything ran in 5 FPS, so it didn't really matter if it was 1, 2, or 4 landscapes. We felt it may be a problem, but we didn't know how much of a problem it will be, and the map was already done, and it looked okay, so we leave it. We left it. A little bit later, when a lot of work was actually recreated, again, after first, second pass of optimization, we found out that yes, those places generate some hitches during loadings. That's not that bad, and probably after some optimization, it will be fixed. And this was a moment when we actually should absolutely change this. We should throw out parts of the design, throw out part of the map, and recreate this. We were very afraid to do this because if it's already done, level artists worked on this, and now they're working on something completely different, on newer parts of the world, and possibly even DLC, we don't want to go back to things that are done and looking okay. And then the game was ported to consoles. And at the beginning, there were a lot of crashes, a lot of problems. But then, sadly and surely, code team fixed most of those problems. And at some point, when the world was done completely, we end up with crashes in just a couple of places because consoles ran out of memory. And those places were exactly those places with 4 landscapes loaded at the same time. So problem was absolutely avoidable, but we didn't fix it when we had time for this. So we end up with much bigger problem. When the world was completely done, everything is done, the team was doing completely different things, and we had crashes that happened every single time whenever train ran into those places. So then we had to fix it somehow, and unfortunately the way to do this was to cut levels into smaller chunks, smaller parts, so only part will be loaded. which meant that a lot of things on the horizon wouldn't even be loaded and look bad. And we had to cut basically everything that was not absolutely necessary. We did it we could do this because we used those blueprints with corridors. So we could make changes in the blueprints and those retroactively spread around the world. So we had to make much lighter version of those blueprints and replace parts of the tracks near those problematic places. And the effect, in the final version, it worked. There were no crashes, but those places looked barren. Basically, anything that was not absolutely necessary had to be removed, and those places are by far the worst looking parts of the game. And the amount of work to actually fix this was significantly higher than any work that we could spend of just redesigning a world and moving those places half a year earlier. So if you see some potential problem over horizon or something that you just finished working, then maybe, just maybe, do it again to avoid problems in the future. Okay, and I think that's all from me, and we'll have time for some questions. Yes, can we have Mike there?
Yeah, I have one very important question. Now that you know what you know after, like, the whole adventure with Switch, would you commit still to the Switch those 2 years ago, or would you just be like, would you take it into consideration when designing the game, or would you just drop the version immediately?
To be honest, the amount of things that I learned during this, we learned as a team, and the fact that final product shipped and was quite well received on Switch, I would say it was worth it. And yeah, I would do this again. But probably I would be much less stressed about this, knowing how much we can cut and simplify it without anyone being angry about this. Just have to accept this is completely different hardware, and things will look differently, will look simplified, and that's absolutely okay. If you start doing those conversions with the approach that it will have to be as good as PC version, then you fail, because it won't.
Yeah. Okay, thanks.
I have a question. When you were calculating excited maps, were you using Vex or Python or built-in nodes?
I prefer Vex or inside nodes, all building custom nodes.
Okay.
So I don't use Python for a simple reason. I'm not good enough in Python to do this that way.
Okay, thanks.
Okay, I think then we're done. Thank you very much. Thank you for your attention. And we're going to the last slide. Yeah.